Hey everybody, and welcome back. So if you're new to my YouTube channel, everything I do is about model aviation and some ultralight stuff, okay? I'd say 99.9% is what I do, and I'm here to try to share my experiences and educate people. What I do for a living, believe it or not, is in between educating people and training people from experiences I've had in my industry forever, which I'm not going to get into that. But one of the things I want to start at the beginning of this video is I've done over 200 videos, and all of them are always positive. I don't put people down, and I definitely don't belittle people. So if you're going to if I make a video and you want to add to that video, awesome. I want all the input in the world, okay? But when somebody says they're confused or they don't understand it, don't write, well, reread it. It's simple. They didn't get it, okay? If they say I didn't get this or I'm confused, don't just say reread it. It's simple. Educate them. Help teach them. Number one, you'll become a lot more legitimate on the internet as somebody who wants to help people and a lot less of a jerk. Okay? So what I'm doing this video for is I did a video called Demystifying Electric Setups for RC Airplanes, and I got a ton of emails saying that it's really helpful, and most of these people are novices. But a couple of them say, could you add on to this video and talk about the design of the aircraft in relationship of the electrical setup? So I'm going to attempt to do this, okay? And sometimes, how do I say this? I've done this so much that I assume you already know some of this. So if you're an experienced RC electric person, some of this might be like RC 101. But if you're a novice, hopefully this will help you. So when I design a, hang on a minute. So when I design an RC plane that's going to be electric, and I'm scratch building it, well, and look, there's a definition of scratch building that I disagree sometimes. If you're building all plans, you're plan building. If you're building off your own plans from scratch, you're scratch building. And I know a lot of people disagree with me, but to me, if you're building all plans, somebody's already designed that airframe, okay? I don't do that. In the last 15 years, I don't think I've designed anything off anybody's design but my own. I mean, built anything off anything but my own design. But let's just say, when you're thinking of electric, people think that, you know, I've got a prop speed, RPM, I've got a prop diameter, I got a prop pitch, which equates to the prop pitch speed. The pitch speed, if the propeller moves through the air at 60 miles an hour, most aircraft can get to 85 to 90% of that because of the drag they have. But you got to have enough pitch speed to get the airplane to fly through the air. Too low a pitch speed and the airplane might not get into the air. Then we think about the motor watts. What's the maximum watts, which equal horsepower, that motor could have? What's the maximum amps that the electronic speed controller can pull? And then you got battery capacity and C rating. Battery capacity is how much capacity does the battery have. The C rating is how fast can you pull the power out of that battery without heating it up or damaging it. The higher C rating, the more current you can draw, okay? So when I design an airplane, all of this is what comes into it. Cube wing loading, okay? How good is a plane going to fly? Cube wing loading was designed for us RC modelers that don't know how a plane's going to behave. The smaller the wing, if you don't change the ounces per square inch or foot, the airplane's going to fly worse than a larger plane at the same ounces per square foot. But cube wing loading takes into account the size, and this is the reason larger planes fly better. One reason I build large airplanes is I can have lower cube wing loadings because I fly electric and don't need a lot of plywood in the airplane. But we think about our electrical setup, and then we think designing the airframe. Is it going to be a scale airplane? Is it going to be just a fun fly plane? Is it going to be something experimental? And then you got to figure out what materials am I going to build it out of. So for me, personally, I looked at the cube wing loading, and then I look at, okay, what materials do I need for this airplane? If this airplane is going to be like a tundra plane that I'm going to land on rocks and ditches and junk like that, it's going to have a lot beefier gear. So we think about that airframe, and then we think about, you know, the span, the area, the weight, the power, and then systems, okay? And when you think about systems, you know, every time you add a system to an airplane, you're adding weight. Add lights, you add a battery and lights. Add brakes, you're adding weight. Something's got to actuate that brake. Landing gear going up and down, retracts add weight. Flaps. Most people go, yeah, but doesn't that give you more lift? Yeah, it gives you some more lift, but it gives you more drag, and it creates a pitch instability if you don't know how to trim that in. But then there's something that a lot of people kind of forget that are novices, is how do I put the power to the airplane I need? I know I need a cube wing loading in that 5 to 7 or 7 to 10 to be the sweet spot, at least for me, DAG. But then what kind of power do I want to have that airplane fly at? You know, park flyers and trainers can use at 80 to 50 watts per pound, okay? And look, some of these numbers will be different than you Google Warriors find on the internet, but this is what works for me as far as watts per pound. I like to be in that 100 to 110 to 120 watts per pound for my airplanes to fly really good, okay? So cube wing loading, your power, and then what materials are you going to build the airplane out of? So when I designed my B-36 257-inch wingspan, I had to make sure I could turn scale propellers, and a scale propeller on this was 21 inches, 3-blade. Okay, so when before I started building any piece of this airplane, I needed to make sure that I could power it. And keep in mind, these motors are behind the CG, so you're going to have to put a lot of ballast in those that airplane. Okay, the real B-36, the engines for the weight of the whole aircraft didn't matter. When you put a A60-16L in there, which is about 3,000 watts of motor, turning a 21-14 prop, you have heavy electric motors. And actually, a 2-cycle would be lighter, in my humble opinion. But I'm digressing. So when I designed this airplane, I want to make sure my cube wing loading was between 7 and 10. I want to make sure my watts per pound were right. And then I want to make sure, could I build an airframe light? This entire airframe with nothing in it only weighed 19 pounds. But the airplane with everything in it weighed 104 pounds. So think about that when you're designing an airplane. The landing gear weighed 22 pounds for this airplane. So, which was stupid. I didn't build them. I had somebody build them for me. And sorry if you know that you build them for me. I don't think that company's around anymore, but they just use so much stainless steel and junk in it where it should have been carbon fiber tubing. It was a disastrous design. But now what I want to talk about is when I tested these motors. Most people think, oh, I got to test the thrust. To me, thrust is irrelevant. Okay, I mean, how do I say this? It's irrelevant in testing. If you have the prop pitch speed you want, which is, I was going to fly this airplane between 50 and 60 mile an hour, so I wanted a prop pitch speed around 75, and you had your 100 to 120 watts per pound, plane's going to fly. Okay, so a lot of times I design these test stands. Sure, I measured thrust, but I was more interested in was I getting enough RPM to get the pitch speed I wanted for the amount of watts that the motor could handle. Okay. Real quick, I want to talk about one of my really cool sponsors, RTL Fasteners. Go to their website, buy $50 or more of their awesome product, use code DA30, and you will get 30% off the order. I've used these little screws at the bottom to hold servos in, hold cowling on, hold canopies on, fairings. Really cool stuff. And they also have little kits that you can carry around, take to the field, or have in your shop when you lose a bolt or nut. Fascinating company to work with. So now I want to talk about my C-130. C-130, and I'm not going to get too deep into it, but it was a systems hog. The retracts were totally scaled, jack screws and all. The back doors, the ramps were exactly scaled. The flaps were actually on tracks. Everything about this airplane reeked heavy weight. My wing loading, my cube wing loading was going to be 10.5, which is still very acceptable for this side of the airplane, but it's higher than what I wanted. But I need to make sure I had my watts per pound, and could I get the prop speed I wanted, pitch prop speed I wanted. So what I did was I designed this really cool 4-bladed prop. And look, if you're one of those haters out there that says this is going to explode, I had over 200 hours of testing on this. I used hydraulics to try to pull the hub apart. Go watch the videos on the testing of this. I threw rags and ball bearings into the prop at max power. It's fine. But this prop gave me the pitch speed I wanted and the RPM. But right as I was getting 80% of the airplane done, I decided to turn it into a J model. And the J model, if you remember, had, sorry about this, I forgot that I was going to show you some more testing. But the J model had a 6-bladed prop. I made this out of carbon fiber. The carbon fiber went tip to tip. A lot of people came out and said this is a crazy design. I tested this up to almost 400 hours. I built 12 of these props. 3 were tested totally to destruction. I had a lot of people say that carbon fiber props aren't hollow. The smaller ones aren't. The bigger ones, if you go buy a Bila prop, cut it in half, you'll see they're hollow inside. Okay? So this became a 6-bladed prop. Tested it. I had the pitch speed I wanted. I had the watts per pound I wanted. The plane would have flown great. But right before I was getting ready to taxi, test it, and do all of that, a really cool guy came along and offered me, everybody has a price, everybody. If you know the story of the C-130, I sold it. And then we had my MSL2. I designed this completely around wing loading and the watts per pound. This airplane flies like a trainer. I love it. I've got a Mozzie I've designed. This is going to be a little bit heavier cube wing loading because I'm putting some massive motors. I want this to fly straight and level about 150 mile an hour. I want it to look like a real Mozzie. I've not started building this because I haven't tested the motor setups yet. I always test the motor setups before I invest in designing a whole airframe. Okay. T-28, same story. It's completely designed. It's probably closer to being built because I've already bought the big motor, the new NUE motor for it, and I'm getting ready to test that this summer. So this probably will become before the Mosquito. Got a 68% S1 pits I designed. This is going to have another big new motor in it, probably going to be about 18 horsepower. It will actually accelerate vertically, like it'll probably have 250 watts per pound, which is going to be the most I've ever had. And then we got my A7 I designed, which is a 10-foot long A7, and it is going to, I'm not even close to having this designed yet as far as what's going to power it. I have no idea what ducted fan is going to be big enough to do this. A turbine could fly it, but I want to keep it an electric ducted fan. It's going to be a massive one, and I don't have the funds right now to even begin to build this, so that's one reason it hasn't been built. Now what I want to go into is, and let me make this bigger here. So basically I've got a really good buddy, and I asked him the other night, could I share this data? He bought Zeroli plans and built a Zeroli F4U, and about 80% into the build, he wanted to turn it into electric. So he had acquired from a swap meet a Rimfire 65cc, 160 kV, should fly it. Our pitch speed is still a little bit low, but this is what his setup is going to look like. So when I talk about building the airframe, designing the airframe, designing the cube wing loading, knowing what your watts per pound is, you then go into one of these eCalcs and go to the Castle website. I like this one the most because it's got a lot of the motors you can buy today on it. Some of the other ones aren't up to date. But this is just an absolutely neat experiment that he's going through because this is going to be a great flying airplane. We do need to get the pitch speed up just a little bit. But one thing I do want to digress to a little bit is to talk about glow engines. Now, back in the day, a glow engine got, well, even today, a glow engine gets about almost all of its power from the top 20% of its power band. So it's got to be almost at full throttle to really be at its maximum horsepower. And back in the 80s, if we wanted an airplane to have more thrust, we'd put a lower pitch. So think about a car, lower gear, it can pull more weight. Higher gear, it's not going to take off from a stop very good, but it will go faster. So with two-stroke engines, the lower the pitch, the more the thrust. With the higher the pitch, the faster the plane went. But if you go into these e-calculators and start looking at some of these different setups, you'll realize that the prop pitch doesn't give more thrust at lower, and I'll show that in a minute. So this is Project S. I can't talk much about it except it's a plane that a friend of mine's building, and it's a go fast airplane. He's just experimenting with going fast. Now the prop pitch speeds on this aren't accurate with what his testing is showing us right now, and I'm not sure why. The airplane is going a lot faster than this e-calculator is showing here data-wise. But here's the 10.6 we tested, and we wanted to match it against this, and he actually, in level flight, was around, I think in level flight, he was around 60 miles an hour, 63 miles an hour, which that means that the prop pitch speed can't be 60, because you can't go faster than the pitch speed. This was it at a 10.8, And you notice the airplane's going faster, but look at the thrust on this. The thrust is going up. It's not going down, because normally your thrust will go down as your pitch goes up on a 2 cycle. On this, it's completely different. And then we go to a 1010. Now, this was kind of interesting here because with the 1010 prop, we still weren't using anywhere near the maximum amp that he could use on the speed controller. So he called me up and says, you know, Damon, what am I doing wrong? The plane's going faster. It's just the watts per pound are low, and you know, blah blah blah. And I said, if you're going to, and here, let me back up for a minute. I want to show you something. So if you're going to go, let's say from the 10.8, and we're keeping the KV and everything equal here, and then we're going to go to the 1010, and his speed goes up, you are adding current and everything to the system. But what we ended up doing is I told him, go up one more cell. And if you look, the current, he's got a 60 amp speed controller. His current is at 5945, which means it's up there. His watts are still safe. But look at his pitch speed. His pitch speed now is 117 miles an hour, which we haven't tested this, but his other 4S was still doing like 90 something. So it's going to be interesting to see why there's a deviation in all of this. Okay, we don't understand it, and we're trying to figure it out. So basically, everybody, I'm doing this just to try to share data that I'm done. I'm not the person who's just going to go off and do an e-calculator and say, oh, here's how your setup should be. I believe 90% of what the e-calculator, I use it basically to check, to make sure I'm in my ballpark. But if we would follow it exactly on my friend's setup here, we're not sure if we would have built it the way we built it, or the way he built it or set it up. So experimentation is really important, but that costs money. You know, be careful of the Google warriors that tell you, oh, you got to do this setup and this setup and this setup. Because if you put it together and it's wrong, it's your money, it's not their money. So make sure that you reach out to people who've actually shown they're doing it. You know, there's a lot more people out there that have really cool, you know, I've only got like 5,000 followers. There's people with 2.2 million followers out there that do a lot more electric than me, that you could follow what they do too. But be wary of the people that just want to use an e-calculator to tell you how to set it up, because they're accurate for a baseline setup, but they're not 100% accurate. Okay. Now on my big airplanes, they're plus or minus 10% or a little bit less. On smaller airplanes, we see a bigger stretch in accuracy. Okay. So I hope you appreciate this video. Please like and subscribe if you haven't. Comment. Okay. Please comment. I want your comments. I want your input, and tell me what future videos you'd like me to make. Okay. So rock on, everybody. Have a fabulous day and be safe. Take care.